Hello there, I'm Jimmy Vegas, and in this mini Unity tutorial I'm going to show you how you can highlight game objects real-time in-game. And don't forget to hit that subscribe button and click the little bell icon to stay up to date with every other tutorial I have on this channel. And with that in mind, let's get our highlighting working. So, I have three what appear to be anvils right here. And the general idea of what I want to achieve by the end of this tutorial is when we look at this one, we're looking at it, we want it highlighting. So it highlights, let's say, yellow. And I don't want to just have it where we highlight yellow. That's it. I want it kind of flashing as well. That's the aim of what I'm going for here. And what we'll need to do is two different scripts. So it'll be in two stages. The first, we'll need to obtain the actual object we're looking at. And the second is then, I say animating, but it's changing the material, red, green, and blue within it to flash. So let's start by creating a C# script, and we'll call this casting to object. And I've used the term casting there, so I'm hoping you guys may know we're going to use arraycast. Now arraycast is mainly used, at least in my tutorials, to obtain the distance away from an object. In this case, we're not going to do that. We're only going to obtain the name of the object, and it is in this case necessary that every object is named differently, but when you're developing, no two objects should have the same name no matter what. It's just a general rule because things can get confusing and mixed up. So you can see, for example, this one's called anvil, this one's called anvil 1, this one's called anvil 2, so they each have unique names. So to do this, what we'll do is we'll get rid of void start and any annotations. We'll start with a string. So we need to get the selected object name, and we'll do that via a string, but it also needs to be static because it needs to be referenced from the other script. So public static string, and we'll call it selected object semicolon. The next one, I'm going to have an internal version of this so we can see it appear in the inspector panel. So it's going to be the exact same variable, just without the word static, because obviously having static makes it disappear from the inspector panel. So public string, and we'll just call it internal object. So there's no other purpose for this but within this script alone. Next is going to be the raycast hit. So public raycast hit, and we'll call it just the object semicolon. So what we need to do in void update is send out a raycast going forward and return whatever object we have, and then set the selected object to the name of that object we're looking at. So if physics dot raycast, and if you want to know a little bit more about raycast, I do have a couple of tutorials within series and also a mini tutorial exclusively on raycast, so you may want to check that out just to learn a little bit more. Transform the position, and then we want to transform the direction going forward. So transform direction, and in brackets vector3 dot forward, and we use vector3 because we're in a 3D environment. Close bracket, semicolon, out, because we're outputting and we want to output to the object. And after that, close bracket, open curly bracket, excuse me, and then selected object is equal to the object dot transform dot game object dot name. So we return the name of the object. In this case, it's going to be either anvil, anvil 1, anvil 2. And we'll also repeat that line. And instead of selected object, we'll have that as internal object. And save that script. Let's head back to Unity and let's check out this script is working correctly. So we'll attach it to our FPS controller, or if you are just using a camera, you would attach it to the camera. So whatever you're viewing through, you would attach this script to it. So through the FPS controller. And we're not going to set anything here, so we should hopefully, when we start the script, start the game, we'll see here appear whatever we're looking at. So let's start. And there we go. You can see anvil 1 has appeared, anvil has appeared, anvil 2 has appeared. So the reason these do appear is because they have colliders on it. It's absolutely necessary to have a collider on whatever object you want this to happen on. If the object does not have a collider, like this building that I'm in, there is no collider attached to this, it will not appear because there is nothing for the raycast to connect with. So if we were to turn the colliders off on these, the raycast would not connect with them. So make sure you do have colliders on those objects. So our casting script is working. Next thing we need to do is create a script which is going to be applied to each of these objects, which will do what we need them to do. There's a little bit of conversion going on within the file as well, but I'll explain that as we go along. So right click, create C# script, and we'll call this selected flash. Open up in Visual Studio, and although originally when I did plan this, I used an integer for red, green, and blue. But to get the yellow effect, I don't really need to bother with the red, so that really won't change. But I'll still put it in there just in case. So, selected flash, we can get rid of void start and any annotations. We don't need them. There's going to be quite a few variables in this one because we need to have certain conditions met before we animate and before we stop. So we'll start with public game object, and we'll also call this one selected object because this is going to be relative to the object, the same one from the casting object. So selected object. Next one, let's have the red, green, and blue colors, and we can go public int red col, public int green col, and public int blue, not glue, blue col, semicolon. Next, what we need to do is check whether we're actually looking at an object or not. So that's going to be a bool. So it's going to be true or false. So public bool looking at object semicolon. In fact, by default, we'll make this false. Next, we need another bool, which is going to be, are we flashing the material or not? So public bool, we'll call it flashing in. By default, we'll have it as true because we want it to start flashing the instant we do look at it. And the final variable is going to be, have we executed this flashing animation? So public bool started flashing, we'll call it. By default, we'll have that as false, semicolon. So the idea of what's going to happen is if we are looking at an object, we want to constantly update the color to make it flash. So in void update, what we need to do is have if looking at object is equal, that's double equal, remember, to true. Then what we need to do is access the renderer component within the object and modify the color of the material. So selected object dot get component, and in spiky brackets renderer open close bracket dot material, and material is lowercase, dot color, and color is spelt the American way, not the British way, equals new color, and it's a capital C on that one, 32, and in brackets we now have to put the red, green, and blue and alpha settings. And as we do this, you'll notice them underline red. I'll explain why in just a moment. But we'll start with going red col, comma, green col, comma, blue col, comma, and 255. 255 is the alpha. That's all that is. And semicolon. And as I said, remember, it's underlined red. Reason for this is because color 32 doesn't accept integers or floats as actual values. So by color, you can change it from 0 to 255 by default on the red, green, and blue. The reason these are highlighting is because we need to have them as bytes and not as actual numbers, i.e. not as an integer, not as a float. To get around that, all we need to do is before each variable, in brackets, have the word byte. And then that will sort that one. Once again, byte. And once again, byte in brackets. So we're doing the little conversion here really, and that's all there is. If you're doing the alpha as well, and that's as a variable, you would just do the same, have byte there. So that's all there is in void update. The next key thing to do is the OnMouseOver function, because obviously we have to be looking at this object for it to actually do anything. So what we need to do is go down and have void OnMouseOver. So whenever the mouse is over the object, it doesn't need to be private, so we can get rid of that. And what we need to do is refer to that other script, remember selected object, and we need to make it a game object. So we need to find the game object that that name belongs to, and we can go selected object equals game object dot find, and in brackets we put the name of our variable in the other script. So casting to object dot selected object semicolon. So what this line is doing here is it's setting this variable, which is a game object, and it's finding whatever name we have discovered from that raycast and placing that game object into this variable. So now at this point, when the mouse goes over it, the object we're looking at is now this object, and that means that we can manipulate this object like we would if we'd have actually applied it in the inspector panel. Next thing we need to do is set looking at object as true, because we're looking at that object now. So looking at object equals true, semicolon. And now what we need to do, because we're starting this next sequence, and by default started flashing is equal to false, we can now put if started flashing equals false, open curly bracket. What we do is set started flashing to true, and then we need to start a coroutine, and we can call this coroutine whatever we want, and we're going to write it after we've written the next method, which is void OnMouseExit. So for now, we're just going to call this this routine, what should we call it? Flash object. Why not? So start coroutine, and in brackets, flash object, open close bracket, semicolon. And that's all there is to it within OnMouseOver. And yes, this is underlined because we haven't written this yet, but don't worry about that, it'll disappear. The next method we have to write is the inverse of this, which is OnMouseExit. So void OnMouseExit. Doesn't need to be private, that can go. So firstly, we need to have started flashing set as false again. So started flashing equals false. We also need to set looking at object false again. So looking at object equals false, semicolon. We also need to stop the coroutine, because inside the coroutine we're going to have essentially a loop which constantly loops around, highlighting and unhighlighting the object. So we need to stop the coroutine. Stop coroutine, and in brackets the same one as we started, which is flash object, open close bracket and semicolon. Final thing we have to do is repeat this line of code, so we can copy it, place it here. However, instead of having these variables, we need to reset it to its original value. In this case, because they're just default textures on materials, it'll be 255. So every value here will be 255, 255, 255, 255. If you have modified your material on these objects in any way, you would reset them back to their actual value. And you can see here 255, 255, 252, them is right there. So if you by default have it as that, you would reset it to these values. But like I say, mine are this initially. So I reset them to that. So that's OnMouseExit all done. So the final thing we have to do is where it gets not too complicated, but it can get a little bit confusing a little bit quickly. Enumerator, and we call it flash object. Open close bracket, open curly bracket. And the first thing we need to do is while, and in brackets, looking at object equals true. So while we are actually looking at that object, so while we want it to be highlighted, we're going to start by having yield return, if I can spell it right, return new wait for seconds, and in brackets we're going to wait for a relatively small amount of time. So 0.05f should probably do it, but again, this number is entirely up to you. It depends how fast or slow you want this to highlight. If you want to highlight quite fast, you would have this as say 0.01. If you want a bit of a slower highlight, you could probably have 0.1. But 0.05 is going to be a pretty decent number to have at this point. So now what we need to do is check whether we're flashing in or flashing out. So if, and in brackets, flashing in equals true, open curly bracket. So by default, remember, it is true, which means we want it to go with a yellowy color. So we can go if blue col, because we're going to be dealing with the blue color in this instance, because changing that to nothing and changing the green a little bit will make it a yellowy kind of color. So seeing the blue one is going to be the one we deal with the most, we're going to have this one, and you'll see how this works now. So if blue color is less than or equal to, let's say, 30, so you want a relatively low number here because you want it to go quite far, then flashing in equals false. So what we've done is, if we've gone all the way down into our desired color, I should say, then we set flashing in as false. So this bit no longer runs. Excuse me. Else blue col minus equals 25 and green col minus equals 1. So I don't want to reduce the green just a little bit. Semicolon. So just to kind of double check what we're doing here, like I say, it can get a little bit confusing a little bit quickly. What we're doing is we're checking the blue color, because that is, like I say, going to be the main color that we change in this instance. And if it's more than 30, then we're going to reduce whatever it is by 25. If at any point it hits 30, then we stop. And we have to do the inverse of what we've done here. So if, in brackets, blue col is greater than or equal to quite high, so not 255, but nearly 255, so we'll say 250, then we need to basically say flashing in equals true. So you can see the loop that's occurring here. It's either going to be one of these two right here. And let me quickly check, have we put this if statement in the right place? I don't think we have. I think we've done that the wrong way around, haven't we? So I think we do actually need another if statement there. See what I mean about getting confusing quickly? We need to also have if, and in brackets, flashing in equals false. Then we need to have that right there. Open curly bracket, and then close curly brackets, then that indents for us. And then once we've got this check here, so remember we're doing the inverse of this one here. So if flashing in is equal to true, we've got flashing in is equal to false. Blue color, changing flashing in again, flashing in again. So then we have to replicate the else statement just there. So else, open curly bracket, and it'll be blue col plus equals 25 semicolon, and then green col plus equals 1 semicolon, and save. Last thing we'll probably need to do is, if you can see here, this one comes down here but has no end. So all we need to do is add in an extra close curly bracket. So that closes the while, this one closes the method, and this one closes the entire class. save the script, head back to Unity, and hopefully we don't have any errors. We can see down here, it's thinking, and we're all good. So this script is now pretty much written. You can use this script on any object in your game at any point. So if we attach that same script to all of these objects, so for example, drag and drop onto Anvil, drag and drop onto Anvil 1, and drag and drop onto Anvil 2. And if we click on it and have a look down here, we can see that we don't even need to set anything. Usually you'll probably drag something over here into selected object. However, I'm going to leave that as it is, and we'll see what happens. So let's press play. I just have a little dot in the middle to represent the middle of the screen. But if we look at this anvil, there we go, we can see changing right there. So it's blue in this case. So, yeah. Now, the reason this has happened can get a little bit confusing sometimes, but there we go, it's highlighted. So that's one way of highlighting. And again, it's all about changing the colors. And I guess it's entirely up to you how you want it to appear, because there's no real set way of doing it. There's no, generic kind of, oh, you should do this. So let's change the, I don't know, what should we have? What shall we have here? Should we change this to red? And let's change this to red as well. And save. And press play. And let's see what we get here. So we have the red flashing. So let's try, gosh, I don't know, let's have this as green as 25 as well, and save. So all I'm showing here is the different things that you could actually do. If you want things highlighting differently, you would have to replicate the script in whatever way you would want. But that is how we can pretty much highlight any object within Unity. And it really is that simple. And you can see, although we're looking at this entire room, it's not actually happening to us at all. And if we add in, let's say, 3D object cube, let's bring this cube here. If we look at the cube, even though it's got a box collider, nothing will actually happen to it. However, if we go to FPS controller, we can still see down here, if we look at it, the internal object actually still becomes the cube. So that is how you can highlight objects. It's all about this single script. And like I say, if you duplicate it, you can change the colors and have different colors completely. Let's try one more just for a bit of fun. Why not? See what color we come up with now. And hopefully, fingers crossed, we have something decent. Purple. And there we go. Excellent. So I'm quite happy with that. So guys, if you want to know any more on this, if you want to go a little bit further, if you think you've got, something a really good idea that this could be used with, please, speak up in the comments below. And guys, remember, subscribe. You'll find tons and tons and tons of stuff on my channel. Fantastic amounts of knowledge to learn with Unity. And with that, guys, thank you very much for watching.